We're going to talk about adding and subtracting functions, and what I want you to think about is, although you've not seen this notation before, where we're adding function x plus function g, the math itself you've seen. I want you to think about combining like terms, because really that's what you're doing. So if you remember how to combine like terms, this should be fairly simple for you. If not, this will be a refresher for you, and that's okay. So we have question number 1. So we're going to do f plus g of x. And they're asking us, what is that? So we know that we have x, and what we're going to do is add to it g of x, which is negative 3x plus 5. So we're just going to combine like terms. I have a positive x minus 3x, which gives me negative 2x. And then I have no other constant, so it would be negative 2x plus 5. Number 2, we have what is f plus g of x. So we're going to take function f and function g and add them together. Well, we see that f of x is negative x squared minus 10x, and we're going to add to that negative 2x squared. So here we have like terms. So negative x squared plus negative 2x squared is negative 3x squared. We don't have another term that looks like our x raised to the first power, so it's just negative 10x. And I know those of you who are in my class are going, buckets! Yes, buckets! So if you want to use buckets, go ahead and use buckets. And for those of you who don't know what buckets are, ask a neighbor. So number 3, we've got, this time, f minus g of x. Now, unlike addition, where the property is commutative, in other words, it doesn't matter which way I flip them, I'm going to get the same answer. When you have subtraction, you must go in the order that you're given. So I'm going to do 5x plus 4 minus negative x squared, because I'm doing function f, which is 5x plus 4, minus whatever g of x is. Well, g of x is negative x squared. So we do 5x plus 4, and if you remember, a negative times a negative is a positive, so that's plus x squared, and we're going to put it in the correct order. Notice that this is a quadrilateral, not a quadrilateral, a quadratic function. So we've got x squared plus 5x plus 4. And notice it says that we are to write our answers as a polynomial or rational function in simplest form. Alright, so now we've got f plus g of x. And they're asking us again, what is that? So we've got f of x, which is x squared minus 8x. And we're going to add to that 2x squared. So we notice this x squared and this x squared, they're like terms, so let's combine them. And we've got 3x squared minus 8x. Alright, number 5. So we've got f minus g of x. So again, we have to go in the correct order. So we've got 3x squared minus negative 5x plus 5. Remember to distribute your negative. So this becomes 3x squared. Negative times a negative is a positive, so that becomes plus 5x. Negative times a positive is a negative, so that becomes negative 5. Now that would be our answer. If you forget to distribute the negative, you'll have an incorrect answer. All right, let's go to number 6 here. We've got c minus b of x. So we've got negative 5x plus 6, and we are going to subtract from it x squared. So none of these terms are the same, but we do have to distribute this negative to the x squared. So we end up with negative x squared. We don't distribute backwards. So it'd just be negative x squared minus 5x plus 6. Number 7, f. What is f plus g of x? So we've got 4x plus 5 plus negative 3x. Combine your like terms for 4x minus 3x equals x. And we have no other constant, so our answer would be x plus 5. Number 8. What is s plus q of x? So we've got 5x, which is s, plus 3x plus 3. Well, we've got terms that we can combine right there, so that's 8x plus 3. And even if you look here and you go, oh, she didn't distribute. If I distribute this positive to a positive, I'm still going to get positive. So really, you only need to remember to distribute when the sign between the two polynomials is negative. 9, we've got f plus g of x. What is this, they're asking? So we've got for f negative 2x squared plus 7x, and we're going to add to that negative 4x plus 3. So we don't have a like term with the negative 2x squared, so we're going to keep that. Well, we have 7x plus negative 4x, which is the same as saying 7x minus 4x, which is positive 3x. We have no other constant, so that's plus 3. Let's see, let me check it. Negative at 2x squared plus 3 is plus 3. And you'll really want to be very careful with IXL. It does not know what you mean. There is no little man in there going, oh, I know. They knew what I meant. No, they don't. It's an algorithm, so you have to make sure that all of your information is in the right spot. So we have what is r plus s of x. R is negative 3x squared minus 6x. And we're going to add to it 4x plus 1. So we have no like term with 3x squared or negative 3x squared, so we keep that. We have negative 6x plus 4x. Well, negative 6 has the advantage by 2, so that would be negative 2x, and then no other constant. Alright, and let's see, I think I'm going to move this up here. Number 11, we've got what is f minus g of x? So we've got negative 3x plus 6. And we're going to subtract from it 3x plus 4. And we're going to remember to distribute our negative. So we're going to leave our first polynomial the same. Negative distributed to the positive 3x. So this is like saying negative 1 times this would be negative 3x. Negative 1 times positive 4 would be negative 4. Now we're going to take and combine our like terms, negative 3x plus another negative 3x, or you could think negative 3x, move left on the number line another 3x, that would give us negative 6x. 6 minus 4 would give us positive 2. Alright, and then finally, let's see. Number 12. We've got c plus a of x, and c is 2x squared minus 6x, and we're going to add to that x squared plus 8x. Well, we've got like terms right here. So this would be 3x squared. Negative 6x plus 8x is positive 2x. All right, you go forth and make it 100.